So welcome everybody to this session, Qt IVI. So what is Qt, or rather Automotive In-Vehicle Infotainment? It's a number of features and subsystems in vehicles. So we have audio and video entertainment as a large group of features, of course, in the vehicle. They include front seat video and audio, rear seat video and audio over separate audio channels, separate sets of headphones, separate audio zones from the speakers at the same time. We have lots of connectivity features, consumer electronics connectivity features, the iPods, USB memories and whatnot that customers expect to be able to, and users expect to be able to connect in the cars. Telephony, the list is pretty long, including navigation, telematics, and other features. It's a big and complex feature set that in-vehicle infotainment is addressing in cars today. So the typical infotainment system of today consists of a number of different units. Normally, because of its complexity and because of the need to segment the features hardware-wise, a system today is split up into several different pieces of hardware. And these communicate over different types of networks. There are a couple of networks that are particularly popular in use by car manufacturers. There's MOST, CAN, and other networks, depending on which type of communication that is made over the network. So we have a head unit, a typical classical head unit with a separate display. This is typically the CD player, radio, DVD player in the front seat, so to speak. Many times we have a separate amplifier due to packaging reasons. The amplifiers, when they're powerful, they emit a lot of heat, so they need to be packaged differently or separately in the car. We have separate connectivity modules. These things are running development-wise at a different speed compared to the rest of the system many times. These are typically convenience ports for USB connectivity, iPod connectivity modules and such. And also, car manufacturers want to be able to offer these as options to customers. We have telematics modules, and these are also separate because of space, just the physical size that they take up, but also due to regional differences of, for example, wireless standards. Whether this module is for the North American market, the Japanese market, or the European market, these differ, and it's many times too expensive for the car manufacturers to combine these, but rather to have them in separate boxes. Rear seat entertainment is increasing a lot in importance in the industry, and right now often this is a separate node on the network also, with one or two displays, in some cases even more displays, depending on the vehicle. This is mimicking a lot of the features of the head unit normally, so it's a really also capable subsystem, of course, for audio and video playback. Then we have digital radio receiver as an example. This again is regional, so there's option specific depending on the geographic region where this is sold, and this together constitutes a typical infotainment system of today. As you can see, it's quite complex, consists of a lot of different modules, and including a network also. So the trends and key market drivers for this particular type of systems is really internet, of course, and location-based services, off-board services, cloud services provided to the vehicle, where the infotainment system in the vehicle is the delivery platform for the cloud services. Graphics, HMI, user experience. Many car makers actually today have on the top of their list the user experience, HMI, and graphics in priority. It's actually the top priority of the entire infotainment system to have a really appealing user experience to the driver of the car or the passengers of the car, the users. Then, of course, after-sales upgrades and App Store needs to be supported. The lifetime of these products and these systems are quite long. You don't throw away your car like you throw away your mobile phone. So you need to be able to upgrade these systems. The acceptance for not being able to do so is lowering all the time. Consumers have their mobile phones. They have their app stores that they can access and download new applications, upgrade the firmware, and so forth. So the tolerance for not being able to do the same with a really expensive system many times in comparison to and capable system in comparison to a mobile phone, that's really lowering. Always connected, the car based on the services that you expect and want to be able to provide in the car is something that requires many times an always connected type of strategy when building the system. So a lot of the services and functions require an internet connection, for example. Low power, again, for different reasons than a mobile phone, low power is really important in a vehicle. You don't want your battery to run out in an hour just because you leave your radio on. Or you don't want to have the battery run out in a week when you have the car in key-off mode in the car park when you travel somewhere. So low power is really important to this system also, or to these kinds of systems. So in short, for partly different reasons, but still, this is very similar to the requirements of the consumer electronics market. It's getting more and more similar to the expectance from users of this system or these kinds of systems get closer and closer to what you expect from a mobile phone or a media player that you buy as a piece of consumer electronics. So the challenging, of course, the challenges of in-vehicle infotainment is that you have a very long life cycle of the products compared to consumer. You're looking at a vehicle that is supposed to run, be serviced, and be of use to the owner for many, many years. And we're looking at 10 to 15 years at minimum for the vehicles, of course. That's a quite different life cycle and much longer life cycle than for most consumer electronics products. We also have a number of specifics, and I would even go as far to say that they're unique, these requirements. There are, for example, networking technology that is used only in automotive and nowhere else. There's a number of standards for network communication, diagnostics, and other things that you will not find in any other marketplace or any other industry. You have multiple screens with different roles. The system doesn't have a single user or is not limited to a single user, but you can have a number of passengers in the car, a driver and a passenger, and there's different limitations, and you want to provide different feature sets and present different feature sets to the driver compared to the passengers. So you need to be able to present or support multiple screens and multiple users with different access levels to differentiate the driver from the passengers for various reasons. You don't want the children in the backseat to be able to fiddle around with the navigation unit. You perhaps want them to see the navigation unit but not necessarily interact with it. And the driver, you don't want to get distracted with information that the driver does not need at the moment. So the access levels that we are talking about here is also a level of complexity here because they actually dynamically change over time. So depending on the status of the vehicle, to avoid stealing attention from the driver, you want to be able to mute or not provide certain information at certain times. And you want to be able to change the behavior of the system so that it's the best user experience for the driver, depending on the driver or the vehicle situation. So, for example, you would take information from the vehicle speed, status, and when we're talking about status here, it could be things like, do I have my door open? Is the stereo on or off? Which volume is it at, and so forth. Sensors and other inputs. It could be parking sensors. It could be temperature sensors, whatnot, that you gather information from and that you tailor the information that you provide through the infotainment system to the user depending on these inputs. There is also legal requirements that require this kind of implementation. For example, in several countries, you're not allowed to present video, for example, TV, in the head unit to a driver when you're driving faster than a certain speed. So as soon as you do that, as soon as the vehicle is moving then faster than a certain speed, then you have to switch the screen to a static screen or mute the graphics entirely. Then also it's a very conservative industry with a lot of proprietary solutions. And this, of course, is a challenge of any company working with open source, open standards, and so forth. It's really very focused and driven by the automotive industry itself, of course, but also very conservative due to reasons of software being developed for an engine control ECU or drivetrain or similar systems, subsystems in the car, of course, is safety critical. So that's something where this conservatism partly come from, of course, when it comes to software. So also looking a little bit at the cost of these things, given that we have just said that this type of system has a requirement set that is very close to consumer electronics products. However, it has a lot of attached challenges and different subtle changes or variations to its requirement set. So a typical infotainment system costs about between 15 and 40 million euros to develop today. And it depends on which type of system we're talking about, a low-end system with very few features, or a full-fledged luxury sedan system with displays for all passengers with top-of-the-line features. And the majority of the development cost is actually software, if you look at these projects. The vast majority of the cost is software development, which might come as a surprise to many people. The software royalty is also something that adds cost, of course, per unit, and that typically is between somewhere 1.5 and 25 euros. So this also varies a lot because the volumes varies a lot for products here. High-end systems might run in the thousands of units or even lower per year be produced, while high volume low-end cars are produced in the millions, or at least 100,000. So what about the systems of tomorrow? What are we looking for, or what are we looking at moving forward? So as for all industries, shorter vehicle life cycles, and let me fix this one. Shorter vehicle life cycles, even if they're still very much longer, the product life cycles than consumer electronics. The car industry, is looking for a reduction of R&D, as for any type of product development, always, of course, striving for this. Reduce the total cost and complexity of the systems, because the systems are getting so complex that they actually play an important role in the overall vehicle development. And being an infotainment system, of course, you can question if that should really be the case, but it's still a big part of the user experience of the car. So from that perspective, it's definitely important. Another very important thing is to reduce the feature obsolescence. Today, during the vehicle lifetime, there's quite a few features that will become obsolete during the lifetime of the vehicle, due to the fact that you cannot update the features, you cannot update many times the system to the extent that you can actually keep those features or use those features. The service providers of off-board services might go out of business or change their business model and might not be interesting anymore to use them, or they might not be supported. And also there might be standards, for example, radio standards and other things that change very quickly. In Sweden, for example, we had digital radio, DAB, running for a couple of years on test, but that's now completely stopped, and we only have test channels. So if you bought a DAB radio in Sweden a couple of years ago, then you don't have much use for it now. And of course, the ever-increasing feature content. We mentioned this before. I mean, it's really running at a raging speed forward. The features that customers and owners of cars are expecting. So how do we address this really complex mishmash of requirements? We're looking at, if we look at details of requirements of an in-vehicle infotainment system today, going through these, we have fast boot. We need to be able to have a low quiescent power when we have the vehicle in standby mode. So we need to be able to boot really fast, start up. You don't want the screen of the car to present first graphics or first UI to the driver when you've already started to drive away. You might want to use your rear view camera when you're reversing out of your parking lot, and you don't want to wait 10 seconds for that. Of course, when you buy a vehicle, specifically as a premium vehicle, you expect the best of breed of consumer electronics features. You don't buy $100,000 vehicle and then you have something in terms of an infotainment system that is actually inferior to your $50 media player that you bought just the day before. So that's also something that, of course, needs to be addressed. App stores, the OEMs want to control these, because you don't want to present just any applications in the vehicle. You don't want the user to just download whatever Android application, for example, or whatever Qt widget, for example, that you could download on a generic device and present it here, because the user experience would be suffering then, of course, because many of these applications are not really made for IVI systems or the form factor of the IVI system screens. So the OEMs really want control over this and also be able to brand the applications and so forth. Even if some of the applications are taken from the open app stores, the OEMs want to rebrand them and also make sure that they can sign them off themselves, what's presented in the car, so that there's a continued control over the user experience. The user interface we touched on before, very, very important. Again, several car makers have actually put that on top of the priority list of the infotainment system, what is presented to the users. High security. None of these applications that you, for example, download from an OEM's app store are, of course, allowed to interfere with let's say, the climate control system. And many times the climate control system can be controlled through the same unit, which means that it's actually a safety-related issue, because you could be driving at wintertime, application crash. If that would also crash and affect the climate control, then suddenly you might not be able to see through the windshield anymore, and you would have actually had to stop because you don't have any hot air reaching the windshield. We have automotive unique things like diagnostics, networking that I mentioned before, and also a combination of course, small memory footprint. Electronics cost is something that is sensitive here. Very long product life cycle and so forth. Application sandboxing is connected to high security. So it's really a mishmash of requirements. So how do we address this? Well, normally you do that through industry standardization and collaboration, right, between different entities in the market. So when typically an industry is faced with a technology fragmentation, this creates collaboration, standardization, because many of these technologies that we mention here are mature. There is no really reason not to agree on a common approach, not to reinvent the wheel, so to speak, for the different system. And that, unfortunately, has been the case many times in infotainment up until recently. So there's a multitude of initiatives in automotive. So, for example, we have AutoSAR, which is known to many of you, I'm sure. This is the Automotive Open System Architecture. This is aimed to address in-vehicle infotainment also. However, it's not been very successful at that, given that IVI is quite a different animal compared to the rest of the systems in the car. Again, speaking about engine systems and so forth. It's moving at a different pace, influenced by the consumer electronics. Then we have in-vehicle networking. We have CAN, driven by Bosch and partners. Something called the MOST Corporation. This is an optical network used for audio and video in many European cars. The LIN Consortium, very narrow band bus for simple control. Avenue Alliance, it's a recent initiative for using Ethernet for streaming audio and video, also in cars. And FlexRay is another more safety related, safety security related bus. So there's lots of initiatives here. Now, what I would like to introduce, and some of you already know about this, is the Geneva Alliance. And this is a non-profit industry alliance that is working with specifically infotainment, or addressing specifically infotainment, and doing so on open source platforms. So really this is one of the first initiatives where an open collaborative alliance in the automotive market space addresses only IVI. And why it's believed that this will be successful, and why I believe it's going to be successful, is because this is an alliance that specifically only looks after or only aims to address IVI. So that IVI is actually running at a different speed and has a different requirement set, and a closer link to consumer electronics is less of a problem because it's less connected to the other parts of, for example, something like an AutoSAR platform. If we just quickly go through the goals as a summary here, it's really the goals of Geneva. It's really to divert resources that we previously used in the industry to create and validate basic software and basic software infrastructure for in-vehicle infotainment. Of course, rather we will use it towards creating customer features. And we do so by creating a common platform that is reused throughout the industry. So now I will quickly hand over to Johan, my colleague here.